there's also going to be a just-in-time compilation process. So when we hand off the code, which is your mini eBPF script, all of the hardening will be checked. It will make sure that it's not going to bypass any of the kernel protection mechanisms, etc. And then finally, we even do one additional layer of hardening, making sure that we don't do funny things with memory, protect against Spectre and things like that. Right?
Since the CrowdStrike
I was just going to say.
See? Every time somebody says the word kernel, then probably a kitten dies. So how do you prevent yourself from, well, turning millions of computers belly up? Again, not you, but the event from, how do you prevent the event from repeating itself?
That event is probably one of the main motivators for Microsoft to actually now enable eBPF as a default in their operating system, right? So eBPF for Windows exists, right? You can search it, you will find the GitHub repo, it's there. The key thing that's missing is it's not a default part of the operating system. So now if you want to start from a security vendor, try to start doing interesting things like Andrew mentioned, look at things at process level, make sure that we can also apply some security enforcement things. If the kernel does not have a syscall that allows you to do that, you need to modify the kernel, right? And like I mentioned, it's a complex piece of code. Mm-hmm. If you make a mistake, everything blows up, mm-hmm. right? While now, because you're using a kernel feature, you use this small program. If you make a mistake in that program breaks, but that program will never be able to kill your kernel.
Okay, so what you're doing is actually getting feedback from the kernel, but you're not touching the kernel itself. Yes. Okay, so you're just putting this right in the middle in a way that you can interact with it, but without meddling or fiddling with it. Okay?
Exactly. Okay. That's why I stress at the beginning that eBPF is a kernel feature. Yes, it's all about custom codes, and yes, it's all about customizing things, but we're consuming a kernel feature, so we're not changing the kernel. We're just giving it additional bits of functionality. It's almost like a loadable module, but again, without the risk of a loadable module, because a loadable module